We're going to be talking about the unit circle, in particular radian measures for our angles, and I'm going to give you a way to know this entire thing. So once you start to identify the pattern, you can basically have the whole thing memorized pretty easily. So if I give you an angle or the trig value of an angle, you'll know the coordinates also for that point. Easy stuff we know. Since this is the unit circle, meaning 1 unit long, we know the radius is 1 unit for this thing. So if we're here at 0 radians, the standard position, the coordinates of that point is just 1, 0. And if you do a full rotation, a full revolution, you're back here at 0. And if you've gone all the way around, that means you've gone 2 pi radians. So you'd be back to 1, 0. Okay, so then if we cut that in half, we'd be at pi radians. So half a revolution would just be pi radians. That'd be at negative 1, 0. And if we cut that in half, so 1/4 of a revolution up here, in degrees this would be 90 degrees. That'd be pi over 2 radians, which gives us 0, 1. And then so that's pi over 2, add another pi over 2, add another pi over 2, we'd be at 3 pi's over 2 down here. What would be 270 degrees. So that'd be 0, negative 1. So those 4 points that are actually on the x-axis or on the y-axis are probably the 4 easiest points to come up with. So now I want to talk about these other angles in the first quadrant. And then once you can identify those and the values associated with those angles, you can apply that to all the other quadrants pretty easily. So let's start with this small one here. This is actually, in degrees, this would just be 30 degrees. In radians, that'd be pi over 6 radians. So this angle here is pi over 6, and I went ahead and drew a right triangle. So I just dropped the vertical line there from the point, drew a right triangle. This is pi over 6. So if this little angle down here is 30 degrees, pi over 6 in radians, and this is obviously a 90 degree angle, that means this is a 30, 60, 90 right triangle. So that's a special right triangle. Okay, why is that important? Well, if you look at the big angle here, this one, which is like 60 degrees, that's pi over 3 in radians. Well, if that's 60 degrees and that's 90 degrees, this is also a 30, 60, 90 special right triangle. So first big idea I want you to notice, these are technically the exact same triangle, just different orientation. So if you have a 30 degrees here at the origin, the pi over 6, the small angle, that's a 30, 60, 90, but we say it's like a 30, 60, 90 triangle that's laying down. It's the exact same triangle as this, except this one's laying down, right? This one's lazy. This one is tall, but this one's standing up. So it's the same 30, 60, 90, but it's standing up. Okay, so what's interesting about that? We don't really care about the hypotenuses for these triangles. We know those are 1 because it's the unit circle, right? That's just 1 radius. So we don't care about those. What we do care about is the side lengths for like the x, the base of the triangle, and then the y. If we were graphing these, that's where our coordinates would be. The x coordinate would be the base of the triangle. The y coordinate would be the height. So as long as you know that these really are the same triangles, except one's standing up and one's laying down, then we'll be in business. So the other choice you have to make is you have to compare 1/2 versus root 3 over 2. And my question is, which one's bigger? 1/2 or root 3 over 2? Because that's going to come down to which side length is which. I think the bigger side is probably obvious to you, but of those two values, which one's bigger? Alright, so if you said root 3 over 2 is the bigger one, you're correct. So what does that mean for us? These are the exact same triangles. The one that's laying down, the shorter side appears to be the height. So that side must be the 1/2. That means the longer side here would be root 3 over 2. So right away we know the coordinates for the pi over 6. Root 3 over 2 for the x, 1/2 for the y. Okay, so if the green triangle is really just the same triangle but standing up, we can tell that the tall side here, that's the bigger one. So that would be the root 3 over 2 in this case. And then the short side here, that would be our 1/2 for the green triangle. So our coordinates for the green triangle, the pi over 3, 1/2 for the x, root 3 over 2 for the y. Okay, so that was for pi over 6, which is the small one, like the 30 degree, and pi over 3, which is the big one, that's the 60 degree. So if you know that pattern, wow, you'll have almost all this thing knocked out. Okay, so where can we apply this purple triangle to? You can probably already see it, the purple triangle. If I use it as a reference angle, pi over 6 as a reference angle in these other quadrants, you can see where else that would apply. Here, for example, so that's a little bit less than pi. In fact, it's pi over 6 away. So this would be 5 pi over 6. The next place in quadrant 3, that's a little bit more than pi, so that would actually be 7 pi over 6, because it would be pi over 6 more than pi. And then in quadrant 4, you're almost all the way around to a full revolution, except for this one little pi over 6 that's left over. So that would actually be 11 pi over 6. Okay, so maybe you can already see where I'm going with this as far as the color coding here. This triangle applies to, well, this angle here, this reference angle, that's also pi over 6. So if I make that right triangle over here for 5 pi over 6, notice the height, it's the same triangle, the height's still 1/2. The base would still be the long side, since it's laying down. It would still be root 3 over 2, but now it's in the negative x direction. So now we're going back negative root 3 over 2, and then we're going up 1/2 still. So the coordinates for that, negative root 3 over 2 for the x, and then positive 1/2 for the y. Okay, so what about 7 pi over 6 down here in quadrant 3? If you consider the same right triangle there, well, we already have our x value here. The base is still negative root 3 over 2. The height, since it's the short triangle, it's 1/2. Just make sure that's negative, because we're in quadrant 3, so this is the negative y direction. So now we have our point for 7 pi over 6. And you can probably already guess where I'm going for 11 pi over 6. If I consider that right triangle in quadrant 4, the height, since it's the short triangle, is negative 1/2. The base we already have, it's positive root 3 over 2. It's the long side. In quadrant 4, the x values are positive. So we have our point for 11 pi over 6. Okay, so let's just take a moment, if you haven't already, and kind of notice this pattern. If you know everything about 11 pi over 6 in quadrant 1, it's the triangle that's laying down. So the base is the long side, that's the root 3 over 2. The height is the short side, that's 1/2. The hypotenuse is 1, but we don't really care about that. What we do care about, root 3 over 2, 1/2. Notice, root 3 over 2, 1/2. Root 3 over 2, 1/2. You just have to be careful with your signs, really, depending on what quadrant you're in. But since this is the same triangle, different orientation all the way around, we have root 3 over 2 and 1/2 in that order. The x value would be the long one, like the base would be the long one, the height would be the short one. Okay, so let's apply that same logic to pi over 3. This is like our 60 degree angle, the big angle at the origin here. So now the height is root 3 over 2. The height's the long side. The base is only the half. That's the short side. So if I look at quadrant 2, if I use the reference angle here for pi over 6, this 60 degree angle, I'm not quite to pi. I'm a little bit short. In fact, I'm pi over 3 short. So this would be 2 pi over 3 for the angle. And then in quadrant 3, we're going here. So we're a little bit past pi. We're pi over 3 beyond pi, so that would be 4 pi over 3. And then in quadrant 4, here's my 60 degree reference angle. So we're almost to a full revolution. We're almost to a full 2 pi. We're actually save pi over 3 away. So that would be 5 pi over 3. So let's start to think about the right triangles here. If I go to 2 pi over 3, I draw that vertical with the x-axis, make my right triangle. The base is still 1/2, except we got to be careful here. The x values in this direction would be negative. The height, since this one's standing up, pi over 3, right? That's like the 60 degrees, so this is the big triangle that's standing up. The height would be root 3 over 2, and this is still positive. So I have my point for 2 pi over 3. For 4 pi over 3, we're going to make that same triangle. Remember, it's the one that's standing up. So now I have root 3 over 2, but it's in the negative direction. The base would still be negative a half. And for 5 pi over 3, make the triangle. So we already know the base is positive a half. The height would be root 3 over 2, and that is in the negative direction. Okay, so we have our point. So now notice for the green triangles, what's the pattern? 1/2 root 3 over 2. Same thing, x value is negative. Same thing, both values are negative. Same thing, y value is negative. So now we've got the pi over 6 out of the way and the pi over 3 out of the way. That's all the difficult stuff. The pi over 4s are super easy. So let's start with pi over 4 here. That's like half of a 90-degree angle, right? If pi over 2 was 90, cut that in half, pi over 4, this is like our 45. So what happens, if I draw the right triangle here, if this is pi over 4, that's like a 45. So this would be a 45, 45, 90. So that's really nice. Pi over 4s always result in 45, 45, 90 triangles. In other words, those are isosceles triangles. So the height would be the same as the base. So I went ahead and drew the little tick marks in here to indicate for the pi over 4, the 45, 45, 90 here, those are equivalent, those two sides, the blue triangle. Okay, and in this video I'm not going to take the time to prove what the special right triangles, what those side lengths are going to be. I'm going to go ahead and give it to you. I'm going to assume you already know. This would be root 2 over 2. So since they're equivalent, both the base and the height would be root 2 over 2. So this actually works out really nicely for us. We're going to permute that root 2 over 2. It's going to be the same all the way around as long as you have a pi over 4 angle. We just have to be careful with our signs. So where are the other pi over 4s? So let's go to quadrant 2 here. Draw our middle angle here. This is our pi over 4. In fact, if I use the x-axis as a reference, I'm pi over 4 away from a whole pi. So that would be 3 pi over 4. And then in quadrant 3, I'd be pi over 4 beyond a whole pi if I use the x-axis again. So that would be 5 pi over 4. And in quadrant 4, I'd be pi over 4 away from a full 2 pi. Pi over 4 away from a full revolution. So that actually gets me to 7 pi over 4. So the great thing about any of these pi over 4 angles is the answer is either going to be positive root 2 over 2 or negative root 2 over 2, depending on what quadrant we're in. So let's just go ahead and consider the triangles for each one of these. So 3 pi over 4, make the right triangle with the x-axis. 5 pi over 4, let's go ahead and make that right triangle with the x-axis. 7 pi over 4. And let's just think. So 3 pi over 4, let's go to this triangle. So all of these blue triangles are isosceles. So each one is an isosceles right triangle. So I can go ahead and make the tick marks here for 3 pi over 4. We know it's root 2 over 2 for both sides. We just have to be careful. The one that's negative here would be the x value, since this is the negative x direction, and then up the positive y direction. So root 2 over 2 for both, we just have to make sure that x value gets the negative. And then for 5 pi over 4, we already know the x value's negative here. And then since we're in quadrant 3, this is also negative in the y direction as well. So root 2 over 2 for both, but since we're in quadrant 3, these both have to be negative. And then 7 pi over 4, back around to quadrant 4 here. We already know the base is positive root 2 over 2 for the x value. And now the height will be root 2 over 2, but the negative kind, since this is the negative y direction. So make sure that root 2 over 2 has a negative on it for the y value. Beautiful. Unit circle completely filled out here. So let's just notice the patterns again. Pi over 6, that's our 30, 60, 90 with a 30 at the origin. Pi over 6 is the small angle at the origin, so this one's laying down. Pi over 3 was the one that was the 60 at the origin, so that's the tall triangle. That's the one that's standing up. And then so all the other pi over 3 triangles use the same coordinates that the original pi over 3 did. If you just think about Pi over 3, what quadrant am I in? Am I the triangle that's standing up? Okay, then that should help me figure out that my x value is short, my y value is tall. Same thing for pi over 6. What quadrant am I in? Okay, pi over 6 is laying down, so my x value is long, my y value is short. And then for pi over 4, you know the answer is going to be root 2 over 2. You just have to figure out, is it positive or negative based on what quadrant you're in. Alright, so why do we have to memorize this thing in the first place? Why do we have to know this? Why is it useful to know it off the top of our head? So now I want to ask you just a couple questions about sine and cosine. So let me clear this circle off really quickly. So the points that we have here are x and y points. Hopefully you already know which one's cosine and which one's sine. So our x value, that's cosine of theta for the unit circle, and our y value, that's the sine of theta, theta being our angle. Okay, great. So as long as you know that, I want to start by asking you, what's the sine of pi over 3? So based on what you know, your thought process should be this. Pi over 3, I think that's the bigger of the two angles we talked about. So that's like the 60 degree. The bigger one, that's the triangle that's standing up. And pi over 3 is in quadrant 1. So pi over 3, quadrant 1, that's the bigger angle, so that's the triangle that's standing up. Sine is the y value. So consider the height of the tall triangle. That must be the big side. So that's root 3 over 2. Okay, let's try another one while we're at it. What's the cosine of 5 pi over 6? Without looking at the unit circle, just think about it in your head. So 5 pi over 6. Pi over 6 is the one that's laying down. That's the short triangle. And then 5 pi over 6, that's a little bit short of 1 whole pi. So that must be quadrant 2. Right, here's 1 whole pi. We're a little bit short of that. So quadrant 2, 5 pi over 6. Since that's the short triangle, and cosine, that's the x value, the one that's laying down, that must mean the x value would be the long side. So in this case, the x value would be the base, the long side, so root 3 over 2. And just make sure, since you're in quadrant 2, you realize it's negative for this x value. Okay, so everything I'm doing here, I want that to be the thought process in your mind. So I'm illustrating it, but I'm hoping that you're kind of catching on and you can think of this on your own. You can do it in your head, actually. Okay, so how about sine of 5 pi over 4? So right away, I like when I see pi over 4. Because I know it has something to do with root 2 over 2. I don't know if it's positive or negative yet, but I know it has something to do with root 2 over 2. 5 pi over 4, that's a little bit more than 1 whole pi. In fact, that's pi over 4 or more. So that would be quadrant 3. And sine is the y value, but it turns out that both the x and the y are negative in quadrant 3. But this y value, the height, for sure, root 2 over 2, the negative kind. Alright, and last one. How about the cosine of 11 pi over 6? So without looking at the circle, you think to yourself, 11 pi over 6, okay, I know that's the pi over 6, that's the triangle that's laying down. Cosine's the x value, so that must be, if the triangle is laying down, the x value must be the long side. And 11 pi over 6, that's really close to 2 pi. So that's only pi over 6 away from a whole 2 pi. So that's actually the one in quadrant 4. So if it's the x value in quadrant 4, the base of the triangle in quadrant 4, this must mean it's positive, and it's the big side, so positive root 3 over 2. You know what? One more for the road. What's the sine of 5 pi over 3? So 6 pi over 3 would actually be just 2 pi. So 5 pi over 3 is a little less than 2 pi then. So that must be quadrant 4, and pi over 3, that's the big angle. That's like the 60. So this is the one that's standing up, the tall triangle. And sine is the height. So quadrant 4, 5 pi over 3, the height for this triangle. So that'd be the big side, root 3 over 2, but since we're going down here in quadrant 4, that's a negative value. So this is negative root 3 over 2. Okay, so these are just some types of examples you could see. I could have asked any of those angles, and I could have done either sine or cosine. So hopefully by now you've either identified a pattern, you follow my pattern, or you have a way to memorize it yourself. I'd encourage you just to practice, try some of these on your own, and then check your unit circle. So do it in your head without the unit circle, and then check to see if you got it right. Hope you enjoyed the video. Keep doing trig.